What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are back with more SAT problems. And this is great timing too, because let me just make sure. Sound check. This is great timing because the SAT is just around the corner. So guys, we are a mere week and a half away from the March 9th SAT. Big day for anybody who's applying to college, and it might be your first time taking it, second time, whatever. But it's coming up, and I want to get you guys ready. So a quick announcement, usually for my live stream schedule, by the way, yesterday I was supposed to do an ACT video. We missed that, but I'm going to be doing that ACT video today after this one. So you guys can have another one week by week. But anyways, for the SAT next week, since we're leading up to the SAT, I'm going to be doing a full session of videos every day, Monday through Friday. We're just going to be hitting the SAT hardcore that week. And we're going to be doing a 5-day cram session. So make sure to tune in on that 5-day cram session. You can actually make really big leaps if you focus and pay attention during that time and watch me solve a slew of problems. It can really get you in shape and ready to go when test day comes on Saturday. I've heard students jump even just in that week by watching regularly over 100 points. So in the math section alone. So make sure to tune in then. Anyways, without further ado, let's jump into the video today, and we will take it from there. Make sure to leave me questions if you have any questions in the comment section. Here we go. Okay, question number 1. An employee at a publishing company administers a survey to 1,200 book clubs across the country, asking what their clubs read in the last 12 months. Latin type, bestseller status, etc. If approximately 32% of the books reported were not bestsellers, which of the following could be the number of long fiction books reported? Okay, so 32% not bestsellers, and I have no idea what it's talking about because I haven't looked at the graph yet. Which of the following could be the number of long fiction? That's what we're asking about. This is the question. Okay. So 32% not bestsellers. Hold on. Got it. Okay, let's think about this for a second. So the total is 1680 for non-bestsellers, and that's supposed to be. I'm really got to think about this for a second. 1680 out of the total, like total, is 32 over 100. I'm doing percent proportion here. This is, I assume, yeah, it's a calculator problem. So we can reduce this to 8, right? 8 over 25. Okay, let's use our calculators now. 8x equals, oops. 1680 times 25. 1680 times 25 equals 42,000 divided by 8. That's 5,250, I believe. But let's double check that. Divided by 8 is, yeah, 5,000. Okay. So the reason why I calculated that is because this value over here, I'm going to fill out the table over here. Okay. So with this, I'm not exactly sure if I'm going in the right way. We know we want long fiction. That's fine. I'm just going to fill out what I know. So I know that the total is 5,250. That's what I just calculated. And I know that then this over here for bestsellers is, let's see. Oh, wait, hold on. Let me make sure I read this exactly right. The table at the left partially represents approximately 32% of the books reported by the book if the were not bestsellers. Okay. And so which of the following could be the number of long fiction? We may not be able to get this exact down to an exact science. Could be the number of long fiction books reported total. Okay. So 5,250. Oh, I got it. We're done, actually. So now I know that this is the total. And look, we've got total. So I can subtract 311, this and this from 5,250. So 5,250 here. Watch this. Let's add these up. 311 plus 2210 plus 1719 equals, and then subtract this from the total. I did it the other way. It doesn't matter. It's 1,010. So this whole part here can be up to 1,010. That's it. All right. That's the max. So, all right. That looks like an 11. Let me get rid of this. Okay. So it's 1,010. That's the most it could be for this total to add up. Actually, it's what it has to be now that I think about it, because I know it's 5,250. So we will get an exact value. It's 1,010 minus 388. Which is 622. So it actually has to be exactly, pretty much 622, because it does say approximately 32%. So what? That's strange. Oh, I'm answering the wrong thing. Oh yeah, which of the following could be the number of long fiction? Oh yeah, not long fiction. This is the long fiction. That's not the total. Sorry, 622 goes over here, and the total is 1,010. So I think that we're talking about. I think because they threw the approximate, I'm just going with the closest one, which is 1,024, because I got 1,010, and again they said roughly 32%. So I think this is right. Let's see if it's correct. Yeah. It's strange, though, that we got a slightly different number. You see, because they set it up just like me. 5,250. 1,010. Okay, there it is. So they got the exact... It doesn't exactly match, but it's very close. Okay, there we go. Good. Next. S equals 0. A particular detector in a particle collider experiment detects the outgoing particles produced by collision. It also records the spin, blah, 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 blah. I don't think this matters. If 50% of the particles detected have a spin of 1/2, which of the following could be the number of delta baryons with a spin of 3/12 to the 2? This is crazy, okay, because they're throwing all this information that is, whenever I read all this scientific jargon, I immediately tune out, because I know it's superfluous in the sense we just have to break down what are the numbers it's trying to get us to figure out. We don't have to understand the science of, I don't know, need to know what a pion is or a delta baryon. That's how they get you, so beware of that. By the way, this is probably harder than anything you'll see on the real SAT. These Khan Academy problems, as they get more difficult, have a tendency to veer off the path of what should be given to really mimic what's on the actual SAT. Won't be this hard. Okay, in particular, I've taken so many of these now, I can say that with a lot of confidence. If 50% of the particles detected have a spin of 1/2, okay, that means about 1,020. Which of the following could be the number of delta baryons with the spin of 3/2? Well, it's got to be less than 93. Okay. We already know. Oh, check this out. 499 plus 472 is 971, which means that these two in total have to be 49 at most, okay? So if we assume that there's 0 pions, then the max that could be 49. So this has to be between, the max this could be is 93 for 3/2, and the minimum it could be, it can't be smaller than, it can't be smaller than what is that? 44, right? Yeah. So it's somewhere between the range of 44 to 93 because the reason why is we need to get this total of 93. So we know this could be 93 and this could be 0. We know that. And then but we also know that there's another 49 has to come in here to get this 1020 because we know that half all the particles, like it says, spin of 1 over 2, whatever fits in this category. See, I don't need to know what this even means. I just need to understand what numbers go where. So we know we're in that range of 44 to 93. We got two values. Oh, wait a minute. Look at this. I missed this. There must be 0 here and here because 976 matches the total. So this is exactly 49. So we know this has to be 44. Has to be. See what I'm saying? Because now we're talking about a match of 93. So it's exactly 44. That's it. I just missed that. Okay, excellent. Next. The manager of a mobile development team surveys 1,000 customers to determine if they're using applications in web-based or mobile. The table left partially summarizes the findings. Where's the table? Okay, let me put this table here. Partially summarizes the findings. About how many customers in the study between 23 and 32 are expected to prefer web-based versions in order to provide evidence that being in this age group is independent of which application. Half, I guess. So 159. No, that's not there. Okay, hold on. Let me reassess this. Oh, I see. Okay. They prefer using applications in web-based or mobile versions when both are available. The table on the left partially summarizes the findings. Are expected to prefer web-based versions in order to provide evidence that being in this age group is independent. Got it. What they're asking is what they're saying is they basically want to know how is this going to break down to know that this age doesn't impact what they prefer. Essentially saying that it's a uniform preference across all age groups based on the total, which means, okay, so we know, sorry, which one? The web-based version. So we know that it's got to be 350. Right now, of the total, it's 354 over 1,000. Should be the same as X over 318. And we just have to solve this proportion. That will give us the answer. So we cross multiply. 318 times 354. And then divide by 1,000. 112.572. I guess it's this. Did I do that right? I think that's right, because I didn't get the exact. That's the only thing that's tripping me up. Okay, it's right. Yeah, they set up that same proportion. Cool. Yep, and they got the same answer. Next. A company conducts a study to understand how employees act during meetings. They observed 300 meetings. The following table shows the results. Overall, employees chose to multitask during 90% of all the meetings observed. Multitask during 90%. Multitask Okay, we can start to fill this out. So this is a total of 160. This is 11. This is obviously 149. 68. Okay, this is 11. This is 7. This is... Wait, can I figure that out? Employees choose to multitask during an in-person. Wait a minute. Hold on. We need more information. Oh, I got it. A company conducts a study. They observe a total of 300 different meetings. So 300 total. 160, 173. So these two add up to 173. This is 127, right? And 68. Hold on. I feel like we're still missing some information here. 148. So this is 127 down here. Oh, wait, we can figure this out, I think. Hold on. 159. Okay, hold on. 149, 159. 159 plus 68. 159 plus 68 equals 227 plus 11 plus 7 plus 3 plus 11 plus 7 plus 3 equals 248. Which means between these two, we have 52. Okay, I feel like I'm getting closer to the idea. So we have 52 there between those two. And then we need a concrete number. Hold on. Employees chose to multitask during 90% of all the meetings observed. So that means that... Oh, I got it. It's a system of equations. This can be x. This can be y. X plus y. This is crazy. This is a hard problem. X plus y equals 52. And we also know, okay, that this is 149. 68 plus y plus 10 over 11 plus x plus 10 equals, oh yeah, plus everything on top. Plus 149 plus 10 equals 0.9. All right, basically, I'm saying the multitask numbers, which I've written up here, over the multitask and the don't multitask numbers equals 0.9, 90%. Let's simplify this a little bit. 159 plus 68 equals 227. So 227 plus y over, I think it's 248. Yeah, 248 plus x plus y equals 0.9. There might be a faster way to do this, by the way. I'm just kind of going with the flow. I think this makes sense. And we need to solve for what is the probability that employees choose to multitask during an in-person meeting. So we need to find y. Okay, so I'm going to use that to inform my substitution decision. So I'm going to substitute in for x. I'm going to isolate x here. X, oops. Doesn't matter, but this is just saves me a step. X equals 52 minus y. I'm going to plug that in for x. So 227 plus y over 248 plus 52 minus y plus y. These guys cancel out. Though this is 227 plus y over, that's 300, equals 0.9. Okay. Then Multiply both sides by 300. That's 227 plus y equals 270. I can do that in my head. Subtract 227, subtract 227. Y equals 43. That means y equals 43. And what did we say? And x equals, not that it matters, but x equals 9. So the percentage, and just make sure these add up to 127 like we thought. It's 50, and this is 77. And that looks right. So far it looks like it's making sense. And then we said, what is the probability that employees choose to multitask during an in-person meeting? It's 43 out of 50, which is 86 out of 100, or 0.86. Come on. Yeah. Man, that was craziness. I mean, look at this. It's just nuts. I mean, it looks like they did it maybe differently. I don't know. Maybe they did it an easier way. But the SAT, with a question of that difficulty, you just got to roll with what comes to you. And I'm obviously, if you haven't figured it out, I'm solving these in real time. I'm not looking at them ahead of time. I'm literally trying to figure them out online to give you a real idea of the problem-solving process that has to happen. So that's how I tackled that one. Okay, hold on. IRM conducts a survey comparing what kinds of gifts mothers wanted for Mother's Day. She surveys 800 mothers and if they wanted tech or blah, blah, blah. Okay, let's again take a screenshot. Okay, the incomplete table at the left shows the results from the survey. One of the studies was that of the mothers that received flowers, only approximately 10% wanted them. Approximately what percent of mothers wanted flowers? Okay. Overall, approximately what percent of mothers wanted flowers? Hold on. 10% of the moms that wanted them, which is 59. Sorry, sometimes it just takes me a second to... So they all received flowers, only 10% wanted them. 10% of 59 is about 6. So that means only 6 wanted flowers. So that means 6 goes here. And then... So it's 6. Hold on, let me just make sure I'm reading this right. Oh, no, I'm sorry. I did this wrong. I thought that was a total. So we've got, I got to add these. 8, 17, carry the 1, 7, 10, 13, 18. So 187. So only 10%, which is about 19 wanted flowers. So 19 people who received flowers actually wanted them. And does that sound right? Yeah, that sounds right. Others wanted flowers. How many moms did they? Oh, and then wanted flowers are all of these. So 11 plus 19 is 30. This is a hard question. 50, 60, 70, 76, 82, 92, 102. 102 out of 800. So 12.7, so about 13%. I think that's right. Yeah. All right. Okay, cool. There you have it. There are all the problems for table data. It's a pretty big category, so make sure you're comfortable with these types of problems. I am not taking the March SAT. I was going to, and I decided against it because my tutoring schedule is just so busy right now. But I'm definitely going to be taking one either in May or June, so make sure to stay tuned for that. That's it for today, guys. I hope it was helpful. If it was, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you all next time. Take it easy.